recorder. And the first thing I will do is to go over the homework assignment unless the class as a whole does not want me to go over that. So should we go over the homework assignment? Okay, we see a lot of nods. Okay, okay. All right. So the homework assignment is a nested trace homework assignment. So I'm going to show the pseudocode first. Okay, so this is not pseudocode, this is actual C code. So this is the C code, and what I'll do is what I did in the past, which is going to my Google Drive, and I will work on this in the file that you guys have access to. So this way, if you want to refer back to the solution, it's easy to do so. And it's going to be in the share folder, and it'll be under today's date. So the entire spreadsheet is going to be named in today's date. So 2024 5 uh 0226. That's the today's date. All right. And I'll do it pretty much the same way that I usually do things, which is to kind of make a screenshot or kind of clip this part. Oh, it is on. For some reason it is not picking up the my computer. So I'm just gonna have to turn this power off, turn it back on. It takes about 2 minutes or so before it refreshes. All right. Well, we just have to wait a little bit. The recorder is already on, so I can still do all the preparation I need to do on this side. So by the time this starts up, we'll have everything ready to go. And I forgot my normal keyboard in another room, so I have to figure out how to. Oh, there we go. Okay, so okay, open that. Do. Right there. Stash it here. Columns on top, and then go to the spreadsheet. There we go. Okay. All right. So we have the actual code on the right-hand side, okay, which is this portion of the screen, and we're going to trace the code, using the spreadsheet itself. So we have to set up the columns, right? So we have to use the first column is about the line number. The second column, you can use dy, just in the order that the variables appear. This is YL, okay, but if you use Y1, that's fine too. Yeah, that's okay. They look about the same. And then we need one for comments. So these are the necessary columns, okay, one for each variable, and then one column for comments, because when we get to the conditions, we have to evaluate the condition and indicate whether they are true or false, because that dictates what line we have to go to next. All right, so these really do not need to be that wide, so we can kind of make these a little bit narrower. And then the comments is going to be a little bit bigger because we have to type, more stuff over there. The line number, I don't think it needs to be this wide either. So this way we can kind of keep everything kind of compact. Okay, so there we go. So we start with a precondition always. Okay, so we started with pre, since the question or the homework assignment did not say anything about the current value or known value of the variables, so they all start with question marks. And then we get to line one. After line one, dy ends up with a 2. After line 2, yl ends up with a 5. After line 3, xl ends up with a 3. And then after line 4, x itself ends up with a 2. So that portion should be fairly easy. Okay. And then we just again get to line 5. On line 5, because it is evaluating a condition, so that means you have to tell me whether dy is greater than 0 is true or false. So what do you think? 2 is greater than 0 is true. Okay, so very good. And then where do we go next? Then we go to line 6. Very good. Okay, we just follow the line sequentially because the condition is true. So now we have x being x plus xl. Okay, so I'll show you a little trick here. Instead of doing the computation by hand yourself, which can lead to like user error, you can just say okay equal to, and then you click on the cells that you want to add. Okay, so you can E6, and then you type plus, and then the current value of XL, which is this cell here. So this is a trick you can do with a spreadsheet, and I highly recommend people to learn how to use a spreadsheet, even though you are going to become a software engineer. A spreadsheet is a really, really useful tool for a variety of purposes. Okay, so learn how to use a spreadsheet when you can, but you don't have to. Okay, so you can still say, oh, okay, I can just add up the numbers in my head. 2 plus 3 is a 5. Okay, so now we get to line 7. Okay, so line 7 is the beginning of a conditional statement. So we have to evaluate the condition of x is greater than or equal to yl. So is it true or false? It is true. Okay, very good. So if it is true, then we go to the then branch of a conditional statement. In this case, the then branch of the conditional statement starts on line 8. And line 8 says, dy has to be decreased by 1. So once again, I can use the spreadsheet function to refer to its current value and then just type -1, and now it is 1. And then on line 9, we evaluate x minus uh, yl and then put it back into x. So this value is now whatever it has currently minus whatever yl is, which is a 5, and then press the enter key, and it does the computation automatically. Is that okay so far? All right. So you are not required to use the spreadsheet, what we call formulae, in order to do the calculation. I use it because it just reduces the chances of error to basically nothing. Um, it's a good thing to learn, but you don't have to do it in this class. So the big question now is after line 9, where do we go? Hmm? Line 5 again, that is correct. Because after line 9, it concludes the conditional statement. The conditional statement is the last statement within the block statement that is a part that specifies what to do when the condition of the while loop is true. So basically, we are done with the body of the loop, and then we have to go back to the beginning of the loop to reevaluate the condition to see whether we need another iteration of the loop. Is that okay? Does everybody understand that portion? Okay, great. So now we go back to line 5 again. And line 5, is just evaluating whether dy is greater than or greater than 0. It is still true because dy has a value of 1 at this point. So now we go to line 6. Okay. Line 6 is adding xl to x. So now, I'm just using the same trick here. This is the current value of x, and we need to add the value of xl, which is this value over here. And now we get to line 7. And line 7 says, we have to evaluate x is greater than or equal to yl. And is that true or false? It is false this time. Very good. And then where do we go? Well, so this is a really kind of big question, because if the condition of this thing is false, do we have an else block to execute? We don't have an else block. So that means if the condition of line 7 is false, we are done with the conditional statement. Is there anything after the conditional statement in the block statement that the conditional statement belongs to? Nope. That was the last thing, right? So we are basically done with the entire while statement, and then we have to go back to line 5. Okay, so that's the important part here is we go straight back to line 5 here, which means we get to evaluate the condition again. Dy is greater than 0 is true because we haven't done anything with dy in the previous iteration. And then we go back to line 6 again. Okay, line 6 is doing the same kind of calculation, which is adding x to xl. and now it's a 6. So now we go to line 7 again, okay? And let me do this trick that I have shown you guys, at least a few times already, which is to move this bar down a little bit. So this way, this portion of the screen, it's not going to scroll with the rest. So, it makes it easier for me to tell, which column I'm on. So line 7 is still evaluating the same condition, but the values have changed because x is now a 6, yl is a 5. Okay, so now we have to say this is true again. So when the condition of line 7 is true, we go into the then portion of the conditional statement, starting with line 8. Line 8 is dy minus 1. So I'm going to do the equation again. This is the current value of dy. We have to subtract 1 from it. And then we go to line 9, which is subtracting the yl from x. So now this value is whatever this value is minus um, yl, which is this value, and it becomes 1. Okay. And then we go back to line 5, and we still have to ask the question, okay? Because just because you can see that if we should exit the loop doesn't mean that the algorithm is ready to do it. So to trace the algorithm means we have to execute a program exactly the same way that the computer would. Okay, so dy is greater than 0 is now false, and now we are basically done. We get to post. All right. So do we have any questions about this trace? Any questions about the format, why we have these columns, or how we update the values of the variables, or the flow, which means which line follows which other line as we execute the algorithm. Are we okay on all of those? Okay, exactly. Okay, cool. All right. So that's the homework assignment, and I hope this helps you to kind of prepare for exam one, okay? Because exam one will have something like this, except you have to trace the algorithm, while you are in class and only on a piece of paper. Okay, great. So having a ruler helps, okay? Because that's how you can draw the columns. Um, all right, cool. All right, so I'm gonna close this one, and it is already in the shared folder, which means if you ever need to reference back to how I did all this, you can go back to the video along with the file that's already in the shared folder. All right. Do we have any other questions at this point? Seeing none. Okay. Well, you can always ask the questions. Okay. Questions are always welcome. So what I'll do is I'm going to take roll first. Okay, I just want to see how many people are here by 9:15. So go to the bottom of the module that we are on, and then go to 2025-0226, and the word today is analysis, because that's exactly what we're doing. Okay, we're analyzing the algorithms, and we're trying to figure out what the program is going to do. So go ahead and sign into Canvas, and basically I'm just taking roll at this point. And if you're doing this on a mobile device, make sure your mobile device, like your cell phone, is on the LRCCD network, because otherwise the IP filter will not let you into the activity. And you have until 9:30 to do it. I'm just going to write the word on the whiteboard in case you need a little bit more time. So analysis is the word. And then you have another 15 minutes or so. I see that most of you are done with this process already. So I'm just going to move on to continue with the lecture. Okay. Are there any questions about exam one, about the questions and also the answers that we have gone through on Monday? Yep, go ahead. I have not decided, but I think it'll be about the same in terms of, how much time it's going to take as the exam one that you saw. So, hmm yeah. So one thing that I do, with all my classes, not just this class, is, I would look at the grade distribution or the score distribution after the exam. And typically I would see, with a normal class, I would typically see like maybe, 10% of the people is like have a way higher score than the rest of the class. So what I would do is I would take the either third or fourth highest score and then make that the new 100% and then scale everybody up accordingly. So that means if I, for whatever reason, okay, make an exam harder than usual, and let's say the highest score is a 85%, okay? The next one is 82, and then the next one is a 81, and then the fourth highest score go all the way down to 70%. The 70% becomes the new 100%. So it just scales everybody up, using that method. So that means, there's a certain, I wouldn't say built in because I still have to look at the grade distribution, to see whether that is applicable or not. But typically I use that approach. So is that okay? Does everybody understand, what I usually do with normalizing the score in case I make it a little bit too difficult? Okay. Okay. All right. All right. So that's a good question. Any other questions before we continue with where we left off, which is pre and post conditions? Yeah, so that's where we left off last Wednesday because we spent Monday talking about the exam one. So, on last Wednesday, we started to talk about the pre and the post conditions. And I mentioned something like, oh, I messed up the line numbers and, I actually went to adjust the line numbers already. Question? Hmm? I am recording. Yeah, I'm recording. Hmm? Oh, okay. Yeah, I haven't put a timestamp up. That's all. But I am recording, so I can put the timestamp back up. Okay, give me a second to do just that. There we go. Okay. All right. So we are now back to the discussion of pre and post conditions. Yes. While statement. Mm-hmm. Okay. Okay. So all right. So let me see if this works. Okay. I have not tried it, but I think it might work. Okay. So I'll go ahead and give it a try. So that means this is something that you can do as well. So I go to this module and I go straight to the end here and I click this button. Okay. So this button will copy the source document into the clipboard. You click OK here, and then we go to Chat GPT, and then we'll say, okay, the following is the class material on nested control structures in a in introduction to programming. I know that's not the title of this course, but this is actually more descriptive. Um, I will ask additional questions in the following prompts. Okay, so shift enter so it can separate this paragraph from the rest, and then I just do a control V and paste everything from the source document. Okay, so now I press the enter key, and ChatGPT now has the actual content of basically what I do in this class, and it will say, okay, go ahead and ask your questions. So now I ask it, okay, Can you give me an exercise that involves a while loop with another control structure nested in it? I would like to practice how to trace algorithms like this. Okay, so that's basically me asking, ChatGPT within the context of the material that we introduced in this class. So press the enter key. All right, so here's an exercise. Okay, so it has a if nested in a while. Okay, there we go. Okay, this one is a little bit complicated, but I think we can do it. Yeah, so we have to trace this. Um, yeah, yeah, but you can now see how you can use ChatGPT in a much more productive way, right? So instead of asking ChatGPT, oh, what is the answer to my homework assignment? You're asking ChatGPT to give you additional practice. Okay, yeah, so we'll go ahead and do this by hand first, and then we'll see whether ChatGPT itself knows how to do the trace, okay? Because that's the other question. The only thing we haven't really talked about in this entire thing is the percent symbol. The percent symbol means mod, M-O-D, or modulo, which is basically the same thing. So B mod 2 on line 4 is basically saying what is the remainder of B divided by 2. Is that okay? Okay, let me just check on whether you guys understand what is remainder, okay? What is 3 mod 2? It's 1, very good. What is 1 mod 2? Hmm? No. 1 mod 2 is the remainder of 1 divided by 2. What is it? Nope. Nope. Come on, you guys can you, try to remember how to do division by hand. What is 1 divided by 2? There's no 2 in 1. The quotient is 0. But then what is the remainder? There's a remainder of 1. 1 divided by 2 has a quotient of 0 and a remainder of 1. Does that make sense to you? No? Okay. So this is important. Okay, so I need to talk about this first, okay? Because this is um essential mathematical concept, in programming. Okay, I know most of us, think, who cares about the remainder in the division? But in programming, as it turns out, knowing what the remainder is after a division is actually useful in many, many cases. Question? So 8 mod 6 would be 2. That is correct. Mhm. So in this case, 1 divided by 2 it has a quotient of 0 with a remainder of 1. So think of it this way, okay? Normally, the division, okay, I'll give you a normal one. So let's say I have, 80 candies and I have a class of, say, 23 students. And I ask, okay, with 80 candies, how can I give every student the same number of candies? That would be the quotient, right? So with this one, it's going to be 3. Okay. So 3 times 23 is 69. And after I give each student 3 candies, I would have 11 candies left. So this 11 is going to be the remainder of the candy that I still have in my pocket because I want to give every student the same number of candies, which in this case is 3. Does that make sense? So now we push it to what we call a boundary case, which means it is one of the extreme cases, which is, oh, I only have 1 candy and I have 2 students in my class. I want to give the 2 students in my class an equal number of whole candies. I'm not going to break a candy into a half. So the answer is nope. The student each will get 0 candies, okay? And I still have that 1 candy left. as a remainder. So does that make sense? All right. So okay, so I'm gonna kind of put this up, okay, even though this is not a class on arithmetics. In a division, this part is called the dividend. Okay, this part is called the divisor. This part is called the quotient, Quotient, and of course this is our remainder. The way these four terms relate to each other is the dividend is the quotient times the divisor, and then just to emphasize, you perform the multiplication first plus the remainder. That is how these four terms relate to each other in a division. Okay, um, it's you know it's really important. I know most of us do not think of division like this, but it's important to understand these four terms in the division because that's actually useful in programming. Unlike calculus, I know you have to take calculus to complete the computer science program, but I'm going to have to say, for most people, calculus is not super duper useful. This turns out to be far more pragmatic and useful in programming. Okay, so this is basically asking what is the remainder of b divided by 2. Okay, so that's what it's asking. Are we do okay? All right, okay. So I'll do the same trick that I did, okay, which is shift print screen, copy the algorithm so that I can, kind of have visibility of the algorithm when I trace it. Okay, so put it always on top, stash it here. Oh, the clock went somewhere because I forgot to make it always visible. So let me do that. All right, so now it's always on top as well. And I'm gonna go to go use the same Google Sheets, except I'm just gonna add a new sheet for the trace of this particular algorithm. So now we have line number. We have two variables, A and B in this case. And once again, we have comments. And I'll do the same thing here, which is to um, reformat the width of the columns a little bit, just kind of compactify things when I can. And that's it. All right, so we have the precondition as nothing and nothing here because we do not make any assumptions about the values of A and B. And then on line 1, A gets a value of 10. On line 2, B gets a value of 1. And then on line 3, we ask, is A greater than 5? The answer is true. So now we go to line 4. So line 4 is asking, is B mod 2 equal to 0? Okay. So this is important too because the equal instead of a single equal is comparison. A single equal means we are doing assignment. Double equal means we are actually comparing to see whether the remainder of b divided by 2 is 0 or not. In other words, it will give us an answer of either true or false. So you look at b, it is 1. 1 divided by 2 has a remainder of 1. 1 equals to 0 is false. All right. So that means where do we go next? Okay, this is a question I want you guys to answer. Okay, because this particular code, the way it is formatted is not the way that I would do it. But once again, in C and C++, the line feed does not matter. Where you break something into two lines does not matter. So can someone tell me, where do we proceed to when the condition of line 4 is false? We proceed to, you can say line 6, but I'm just going to say line 7 because line 6 is a marker. It doesn't have anything to do other than the purpose of line 6 is to divide the then portion from the else portion. So that's its purpose. So when we trace, we do not typically trace line 6. If you trace line 6, I won't take any points off, but we typically don't do that. So we just go straight to line 7. And line 7 says A gets a minus 1. Okay, so I'll use the same approach as the previous trace, which is to use your spreadsheet formula to do something like this. And then where do we go? We go to line 9, right? Okay, so we go to line 9, and B gets incremented. Okay, so B is 1 more than what it was. And then where do we go? We get back to line 3. That is correct. Okay, we go back to line 3, and then we ask, is A greater than 5? The answer is yes, it is still greater than 5. So as you can see, this is going to take a little bit of time. Okay, and then on line 4, we evaluate the condition again. The remainder of B divided by 2 equal to 0 is, it is true this time, okay, because B is now a 2. 2 divided by 2 has a remainder of 0. Okay, so now this is true, which means we go to which line? Line 5, that's correct. Okay, so this time we take 2 away from A. So now the value of this new value of A is 9 minus 2, which is a 7. Then we go to line, nope, we do not go to line 7. Nope. What is after the, so, nope. Okay, we are just done with line 5. Okay, line 5 is the then statement of a conditional statement. So now you have to remember the flow chart. Okay, the flow chart says, okay, you go to the diamond, okay, with a conditional statement. If it is true, you go to one side and perform whatever is on that side. If it is false, you go to the other side and perform whatever the other side says you have to do. What do we do after that? They merge and they exit. Okay, so that means in this case, after we perform the then statement of the conditional statement on line 5, we are done with the conditional statement. So that means the next line we need to execute is line 9 in this case. All right, so we get to line 9, and line 9 is just adding 1 to B. So once again, we have B plus 1, and then we go back to the beginning, which is line 3. And then we evaluate A is greater than 5. It is still true because it's 7 right now. So I think we have 2 more iterations to do before the whole thing concludes. We get back to line 4, and we are evaluating B mod 2 equal to 0. And it is false this time, okay? Because B is 3. 3 mod 2 is the remainder of 3 divided by 2 is, it's not false. Is 1, okay? 1 equal to 0 is false, okay? So you have to kind of divide the answer to 2 stages, okay? So this one is false. So that means where do we go? Line 7, that is correct. So line 7 is subtracting 1 from A. So this is the current value of A. Subtract 1 from it. And then we get to line 9 again, which is adding 1 to B. So now this is B, and then plus 1, like so. And then we get back to line 3. A is greater than 5 is true because it is 6. 6 is greater than 5, just barely. And now we get back to line 4. Line 4 says, okay, tell me what is B mod 2 equal to 0. The answer is true this time. Then we go to line 5, which subtracts 2 from the current value of A. So we subtract 2, it is now a 4. And then we get to line 9. We add 1 to B. And this is actually, you can see how what the AI is doing. It is recognizing, quote unquote, a pattern of how the formulae are going to be applied. I did not type this, okay? All I did was the equal. That's all I typed. The AI says, oh, you probably meant to say C16 plus 1, which in this case is actually correct. Okay, so that's what AI is capable of doing, which is recognizing patterns. Okay, that's what it's doing. It's recognizing, oh, there's a pattern to how I use the formulae in this particular spreadsheet. Question? Oh, okay, just stretching. That's fine. Okay, so then we go back to line 3 again. And this time when we evaluate a is greater than 5, it is now false. So that means we exit the loop. There's nothing after the loop, so we get to post right away. Do we have any questions about this particular trace? Okay, the question came from ChatGPT. Okay, it came from the AI. So now is the fun part. Okay, the fun part is to go back to the AI and see whether it has the correct answer too. So it actually gave us a table and it asked, do you want me to go over the solution? Okay, and okay, I'm gonna have to get this out of the way. Okay, delete that one, and we'll say sure. Okay, I have completed my own um, trace as follows. Okay, so you can actually have ChatGPT to try to um, how do you call it? How check your answer. Okay, okay. So let me show you how we can do this. So because this is a table, okay, at the end of the day, this is just a table. So as a table, you can export it or save it in a particular way that makes it very easy to upload to ChatGPT. I would recommend saving as a CSV or comma separated file, comma separated value file. Okay, there we go. So I click this, and I'm gonna save it as loop.csv in my temp folder. Okay, you can upload it. Okay, so you can now go to the AI engine here and say, let's see, I think there's a way to upload, open in Canvas plus. Okay, there we go. Okay, as the uploaded file. Okay, so plus, oh, it can actually add from Google Drive too, which is kind of handy. But since I saved it already, I'm gonna get it from here. I called it loop.csv. Okay, there we go. Click open. Okay. Yep. Can you evaluate my answer? There we go. See, I think this is really good. Okay, I think this is really helpful if ChatGPT can grade it correctly. All right. So ChatGPT is analyzing. It's taking a long time. All right. So this is my trace table. I have displayed your trace table for review. Let me know if you would like me to check for correctness or provide any feedback. Okay, so I say, yes, please check for correctness. Okay, all right. At Folsom Lake College, they have specific AI classes to teach people how to use AI. I kind of like the more integrated approach. I just sprinkle the use of AI when I think like, maybe we can do this with AI. Let's give it a try. Well, I guess there are at least 6 bottles of drinking water gone by this time. You guys know about that, right? How AI needs a lot of cooling, and as a result, it consumes, quote unquote, consumes water. It's for cooling. Yeah. hmm So the best way to use that, excess heat, which is a waste, from the AI, data center, is to build the data center, right at the edge of the ocean, so that you can use that power for, making water, making potable water, and then you build a nuclear plant next to it to supply the actual power. So the power would first be used by the AI data center to do all the computation. The heat, which is a waste, from the data center, will then be used to evaporate water, separating water from salt and other minerals. So now we have distilled water. And then you can add back the essential elements or the essential minerals to make that water potable. Because we cannot drink um, distilled water. Okay, it doesn't have the minerals that we need. So anyway, all right. So let's see incorrect trace entries. Okay, And why does it think it is incorrect? There are some mistakes. I've highlighted the incorrect entries for your review. Okay, so where's the highlight? Where did I mess up? Okay, let's maximize that. Okay. Yeah, but I want to know how it is wrong. Huh? Oh, okay. No, that's not it. Oh, you mean this one? Nope, that's not it. I cannot see why it thinks it is wrong. That's the problem. That's this table. All right. It ends up with a three. Oh, okay. So it's a four and B increments to five. Did I forget to increment? I don't think I forget to increment. So, okay. Huh? You mean this one? Yeah, we did that earlier. It basically just this is what it thinks is the correct trace. Comparison. This is how it wants to do the comparison. Alrighty. Okay. All right. I would just ask it. Show me the difference. Show me the differences between my answer and yours. Okay. I think in your generation, it is particularly important to understand what it can do and also what it cannot do. Specifically, what it cannot do. Because that would be the reason why you get hired is to do things that the ChatGPT cannot do. All right. So I'm just looking at the format of the output. I've displayed comparison of your trace with the correct answer. Differences are highlighted for easy identification. What do you mean by highlighted? What? Huh? So every line of the comments is highlighted. So it just thinks the comments is not correct. Okay, well, okay. So I'm gonna ask it. Okay. So why do you think the comments column is incorrect? I think it doesn't understand what a column is for, so it thinks that's why. Okay, good question. The comments column difference I flagged were based on exact text comparison. The logic of your comments may still be correct, but if the wording differs from my expected output, versus okay, so it's true, it wants to spell out the word true as opposed to just abbreviating it to T. To verify correctness, let's focus on whether your comments is accurate or accurately reflect what happens in the program. Rather than just bind the text, I can manually review the flagged differences and confirm. Please, please uh, manually review the flagged differences. I use T and F to represent true and false respectively. There we go. Just to give it a little bit more hint. Thankfully, then your comments are not logically incorrect, which is a very GPT way of saying, I guess you were right. No logical error. Okay, very good. Okay, so that's and interaction. Okay, because when the output of ChatGPT is not what you expect, you don't just go, okay, ChatGPT is wrong, but why is it wrong? How? What is the mechanism behind the conclusion coming from ChatGPT? So always ask that extra question. Okay, yeah, always. Mm-hmm. Yep. But now you can see how this can be useful, right? Because you don't have to send your answer for ChatGPT to grade. You can always just ask ChatGPT, what is your answer to this question, and then you can manually control, compare your answer versus the generated answer. None of this tool existed when I taught this class last in 1999. But then again, back in 1999, finding a job as a software engineer was not nearly as difficult as it is today. You guys won't be looking for a job as a software engineer for another 4 years, easily, at least 4 years. Okay? So the question is, what is going to happen in 4 years? So that's something that I have been looking into, not only because I teach this class, but also both of my kids are in one is in computer engineering, the other one is in math and computer science. So they encounter basically the same kind of challenge. So I do all kinds of research to find out what is happening, what is the trend, and what are we supposed to do, right? Well, because I search those things a lot in Google, so Google gives me, a feed with a lot of those topics already. So um, I can, kind of pop a few here. I know it is not related to algorithm design, but I think ultimately it is related to the long-term goal of every single one of you here. So let me just kind of look for certain keywords so I can, because I was just talking about this with my colleagues earlier. And let's see. Oh, this one is going to be good. Okay. So I can type in the search engine here the title of the article, the career ladder for software engineers is collapsing. Yep. So that's mm, is it from Business Insider? Yep, that's it. Okay. Well, you guys can read the article at your leisure. Okay. But the bottom line is, um, the amount of entry level software engineer, the jobs for entry level software engineer is decreasing. Okay. And the trend is continuing. Okay. Um, Even the mid-level software engineers, if you keep your eye on the news, Meta has just fired 3,600 plus employees. Now, they may not be all software engineers, they may not be all mid-level software engineers, but there are software engineers being fired from Meta, from many other companies. So AI is writing more than 25% of new code at Google. Mark Zuckerberg said that Meta will build an AI engineer to write code. Salesforce CEO Mark Benioff announced a hiring freeze for engineers in 2025, saying AI had increased productivity by 30%. And then news broke that Salesforce planned to lay off 1,000 workers. In other words, at first they just say, okay, we're not going to hire new people because the productivity increase that we need can be done by AI alone. And then they turn their back and go like, wait, it is so good. AI is so good, we can let go of 1,000 engineers and still be able to keep up with the productivity that we need. That's basically what Salesforce is saying. Okay, so the whole article is a little bit depressing, I would say, from the perspective of people who are trying to get into the field at the time, at right now at this point. But it's not all bad, okay? Because the article also turns around to talk about, you know, the nature of a software engineer has changed. So the question is, what do you need in order to become, quote unquote, the next generation of software engineers? Okay. So instead of doing the actual coding part, you might need to focus on what the program is supposed to get done. In other words, you specify the correct behavior of the program, and you might be able to leave it to the AI to generate the code to do it. Does everybody understand what I just said? Instead of, instead of riding a bicycle where you are the one you're pedaling, providing the actual energy to go from point A to point B, while also doing the navigation, watching the traffic, and so on and so forth, you're now saying, oh, I can leave the pedaling to the motor, okay, because I have an electric bicycle. Okay, cool. But you're still, navigating. You're still going like, okay, where am I from and where am I going? And so you still have to keep track of where you are and so on. But the next level up is to have a self-driving bicycle where you just have to tell the bicycle where you need to be by what time and what streets you want to avoid for one reason or another. Okay, I know there's a really bad dog around this neighborhood that's always chasing after me, so exclude this segment of this street from my route. So you have to specify that. Okay, but once you specify that, okay, I need to get to text class. I need to be at ARC by 8:55, so I have time to get to the classroom. I want to avoid this segment of this street because of a pothole. That segment of the other street because of dogs and whatnot. And now the bicycle will take you here. All you have to do is to get on the bike, and you end up here on time. Okay, I think that's analogous to what is happening here. So instead of doing the whole thing, you are now trying to specify what do we want to get done, but with precision. Okay, and that is the part where it connects miraculously to what we are talking about here. All that crazy math stuff is how we can specify with precision what a program is supposed to do. Is that okay? All right, because natural languages is intrinsically I wouldn't say confusing, but it doesn't have the precision to talk about, okay, this is exactly how I want this algorithm to do. Okay, so understanding the math notations is important. Understanding, the reasoning, okay, the things that we just talked about here, that's also important. Is that okay? Any comments, feedback from you guys? But then how do you talk to the AI, right? But then how do you talk to the AI? How do you describe what a program or what a system is supposed to do? That becomes the next question. Now, there are certain things that we can easily communicate, with another person because the other person can always follow up with a question. It's like, I don't know exactly what you mean by this. Okay, I have five ways to interpret what you just said. Exactly which way did you mean? Okay, so you can say, oh, it's none of those five. I actually meant the sixth way. Okay, that you haven't even thought of yet. But the AI does not necessarily have the ability to look at one single statement and go like, "Oh, I can interpret this in six different ways. Which one did you intend?" Yep. Well, that's beyond just human reasoning. That's critical thinking. Critical thinking means, you think of, okay, you tell me something, you said one thing, okay, a statement, and then I go like, oh, okay, I understand it as this, and then I go back and self check. Then I double check and like, is that the only way to interpret what you just said? Now, if the answer is no, then I go like, oh, okay, so there are some alternative interpretations of what you just said. Confusions happens all the time with human communication because we like to use articles like, this, that, it, and so on and so forth to refer to something that we mentioned earlier. But that's not always clear what we were referring to with those words. So sometimes you can have a confusion, because of the use of those things, right? And the AI may make an assumption and not to question its own assumption. But a person would go like, okay, what do you mean by that person. Did you mean this person that you just mentioned before, or that other person that you mentioned before? So that's critical thinking, which led me to another article. Okay, I think this is also going to be interesting. So I'm talking about things that I think are ultimately related to this class and ultimately related to what you guys want to accomplish, even though they do not seem like they are related. Okay, this one is from Psychology Today, and the title of the article is Why I Stopped um, Caring About Enhancing. There we go. This is the article. It's a blog, okay? It's not really a full article. It talks about how this particular psychologist, Dr. Christopher Dwyer, has given up on teaching other people how to think critically. And his conclusion was not out of frustration. It is more out of, just science. It's just, when people are not ready to think in a critical way, there's no way you can teach someone to think critically. So whoever a person needs to realize, oh, okay, I need to practice this. This is something that is ultimately helpful to me. Then that person is receptive to being taught how to think critically. Some people just are born to do this, okay, because they just question everything. Okay, so if you want to know what is critical thinking, just think of a person. I'm sure you have encountered many of those people. Possibly, hopefully, it's the person in the mirror that you see every day. Okay, people who keep asking questions. Okay, people who say, okay, isn't this obvious? No, it's not clear to me. Can you tell me why blah 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 blah, or how blah 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 blah, or what is that? Okay, so critical thinking and asking questions are very related. Okay, you can even ask ChatGPT these questions too. So I would say this is another really good application of using ChatGPT. And I'm going to start a new conversation for this one. Okay, so let's see. Um, hmm? Sorry, new chat. No, no, that's exactly what I want. Okay, explain what is critical thinking and how it is essential um, as a quality of a software engineer. Oh, okay, go back. Okay, there we go. So it gives you the full explanation. It is the ability to analyze information, evaluate different perspectives. In other words, you look at one thing and then you say, is that the only way to look at it? Okay? Make reasoned judgment. It involves logical reasoning, problem solving, and the ability to assess situations objectively without bias. In other words, you have to be aware of your own bias first to make sure that when you evaluate something, that bias did not apply. Okay, key concepts, blah 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 blah. And why is it important for software engineers? And I think this part does relate to you. Okay, because if you're in this class, chances are you are thinking about being a software engineer or someone who is in a similar capacity. Problem solving and debugging, code optimization, efficiency, architectural and design decisions, safety or security and risk assessment, collaboration, blah 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 blah. So there's a whole long list of things why critical thinking can be useful, can be helpful if you want to become a software engineer. So I'm just illustrating different things you can do with AI, and you can do all this without paying too. Okay, the free account allow you to do most of the same thing already. So are there any questions, any comments, based on what I have demonstrated? Nope. All right. Yeah, go ahead. Hmm. Yes, yes. So, so because you still need to evaluate the code that is generated by AI, then you cannot evaluate. Yep. Hmm. And you can even, okay, this is another step up. You can manually write a program. So your program, which you create manually, you can use that program to systematically test or evaluate the code that AI generates. So you are creating your own tool to evaluate the output of AI. You can do that, okay? If you're, at that level of programming. But that means you still need to know how to program. You cannot just leave it to the AI to go like, oh, okay, the AI generates code. I can trust it 100%. We're good. Job well done. Okay, I'm just gonna move on. So you cannot do that, right? Hmm. Because you still need to be able to evaluate what the tool is doing. Is that okay? Okay, all right. So I hope this is helpful to you. Not just, oh, we just blew an hour of time talking about something that has nothing to do with algorithm or coding. I think it really does. Because you're not going to be writing code the same way that someone of my generation wrote code as an engineer, as a software engineer. So you'll be focusing a lot more on what the program is supposed to do as opposed to how to get it done. Okay, so it's the what versus the how. Okay, the question is, are we focusing on how it is done? And then we talk about we spend this much time to talk about why it is done, this much time to talk about what it is that we need to get done. And then with traditional software engineering, we've spent this much time to figure out how to get it done. The AI shift means you still need to ask why and becomes more important. Okay, and then you spend even more time to talk about what is it that you need to get done, and then you spend only this much time to figure out how it is done, because the AI can help you with the how portion, but it cannot help you with the what portion, and certainly cannot really help you that much with the why portion. Yep, that's why you still need people. Yep. Yeah, yeah, go ahead. Hmm. Hmm. Okay, that's a really good question. The question is, what? Yes. So JavaScript is worth learning for multiple reasons. Um, because JavaScript can be used for client-side scripting. In other words, whenever you see a web page in a browser, that's called quote unquote client side. The web page itself is running on the client side, which is your own computer in the browser. That's JavaScript. JavaScript as a language is actually called ECMAScript, ECMA script. It can also run on the server, so you can use it on server side as well. In other words, when it comes to ChatGPT or Canvas, most of the websites like Amazon, there's significant server side scripting, because the server side script has to go to the database, retrieve what products and pictures of the products and the price of the product, and is there a deal going on, blah 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 blah. That has to be retrieved on the server side, so that's server side scripting. And then on top of that, there's also Google Script or Google Apps Script, okay, which allows you to um, customize your spreadsheets, okay. In other words, in the spreadsheet that we just looked at here, I could actually automate this answer here. I can make my own function in order to make that happen. I can write some code to simplify the whole thing. I can make it automatically generate the trace if I wanted to. Okay, so that's Google Apps Script, which is also in ECMAScript, which is basically the same language as JavaScript. So that's why JavaScript is worth learning, because there are so many things that you can do with the programming language in different contexts. Python is definitely worth learning because it is used a lot in all kinds of automation. So both of those are worth learning. Of the two, because you have to learn C++. Plus plus. That's your next class. Okay, you guys don't really have an option but to learn C++. Plus plus. C++ and JavaScript are syntactically similar. So that means once you learn C++, learning JavaScript is like that. Yeah, it'll be a lot faster. It uses the brace, it uses the word if, the word while, the word do, and basically the same kind of syntax. So that's why I think after C++, if you want to learn on your own, you know, JavaScript would be the next one to learn as opposed to Python. Python is a kind of syntactically, it is its own thing. But in terms of concept, once you learn two programming languages, the third one is going to be easy because it's the same concept. It's just packaged differently. Yeah. So that's a good question. But that's my assessment, at this point of, what would be the, whether it's worthwhile to learn JavaScript, and the answer is definitely. Yep. Any other questions? All right. So if there are no other questions, then we're going to go back to the math stuff, okay? All right, so we talked about the inverse function before, um, and I fixed the line numbers, by the way. So the line numbers of all this discussion is already fixed. So instead of doing it in a kind of really static way, I am going to, okay, I will copy that on my tablet, and then we'll switch to the tablet to get a more graphical view of what the code is doing and what we are really doing with um, the pre and post conditions. So I am just copying the code right now, and then I'll switch to the tablet screen. Okay, now I switch to the tablet screen, which should still be here. There we go. All right. All right, so the question is, what is the condition right at this point? Okay, so the condition right at this point can be seen. Okay, let me give you the line numbers. This is line 1, line 2, line 3, and line 4. So the condition that is right here, okay, let me see if it doesn't, nope, doesn't pick up but it picks up when my pen is hovering, so that's fine. So if I'm talking about right here, what is the condition? This is known as post 1. In other words, it is the post condition of line 1, which is the same thing as the precondition of line 2. That's just a notation thing. Okay, I use pre and post to mean, okay, what is the post condition? What is the precondition? But both of these is really just saying, oh, okay, we know now that x equals to 0. And I put parentheses around this because this is an assertion that x and 0 are the same. Is that okay? All right. So now when we look at the post condition here, okay, this is known as post 2, the post condition of line 2, which is exactly the same as the precondition of line 3. And that would be, oh, x equals to 0 is still true because line 2 does not do a single thing to variable x. Whatever we knew about variable x is still true at this point. Do we agree on that? Okay. And on top of that, we also know that y equals to 2 because of the nature of line 2 itself. So this symbol here, okay, this little symbol here that looks like a wedge, that is the same thing as ampersand, ampersand. Okay, so if you want to make a little table for yourself, wedge and double ampersand are exactly the same thing, which is also what we use the and word in English to represent. It's conjunction. Are we doing okay so far? Hmm? Ampersand, ampersand? Yes, but we talked about that. Okay, wedge. Yes, yes. This is the mathematical symbol. This is the C++ syntax. And this is just a word that we typically use to mean the same thing. All right. So the problem is line 3. Okay, line 3 is something that is interesting because what do we know that is true after line 3? Now, you guys can all say, well, since x is a 0, and we are adding 3 to x and put it back into x equals to 3. Yes, okay, that is true. But how do we derive that? Okay, from a mathematical perspective, how do we derive that? So the way we specify that is the post condition of line 3, which in this case is also known as the precondition of line 4, is using substitution. Okay, so I'm using substitution SUB here. We are taking whatever post 2 has. Post 2. We look at all the occurrences of x, and then we replace all the x with, in this case, x minus 3. That is how we derive post 3 from post 2. So what is the whole purpose of this? I mean, we have already talked about how to trace an algorithm already. So why do we have to do something like this, which seems to be overly complicated for no particular reason? Okay, so we'll go through the whole derivation. Post 2 is um, x equals to 0 and y equals to 2. And then we take all the occurrences of x, replace every single one of those with x minus 3. So after the substitution, then we have x minus 3 equals to 0 and y equals to 2 after the substitution. In other words, I take this x here and replace it with x minus 3 over here. So if you know algebra, then you can go like, oh, okay, so if I just make everything nice and neat, that means x equals to 3 and y equals to 2. You go like, yep, that is correct. Okay, but we could have just traced the algorithm and come to the very same conclusion. So what is the big deal of doing it this way? Well, as it turns out, doing it this way is very useful and important when we get to control structures, because we don't have a control structure here. This is just a sequence. So are we still doing okay so far with the use of a pre and a post condition? And in this case, the reason why we can use substitution is because the operation is undoable. When you look at, if I define function f as x plus 3, then the inverse function of f is going to be x minus 3. What does that mean? Now, we talked about inverse functions a little bit last Wednesday. Do you guys still remember what is an inverse function? If you, it's the undo, right? Yeah, so if you apply the inverse function of f to function f to some x here, okay, in this case, I can actually just expand the whole thing. So now I can say, okay, f inverse of x plus 3, but that becomes x plus 3, the whole thing, minus 3, and that's just x. Okay, but you can also do it the other way around. You can also say f inverse apply to x, and then you apply f to the whole thing. So now it becomes f of x minus 3, which is x minus 3 the whole thing, plus 3, which is still x. So that's the nature of something that is reversible. Is that okay? So every time the right-hand side of the assignment is something that is reversible with respect to the left-hand side, we use substitution to derive the post condition. Okay? So in this class, I'm not, so you can quote me, and it's getting recorded too. You can quote me, I will not ask you guys to derive the pre and post conditions of the algorithms that we will be writing. But it's important to get an exposure to the concept, okay? So things get a little bit more interesting when we get to conditional statements. So when we get to conditional statements, okay, so I'm just fast forwarding a little bit here. So when we fast forward to conditional statements like this, okay, so in this case, line 1 is the condition, line 2 is the then operation, line 3 is just a word to separate the then versus the else, and then the line 4 is the else operation. Line 5 does not belong to the conditional statement at all. So basically, when everything is done, I can say by the time we exit the algorithm, x is greater than y and z equals to x, or x is less than or equal to y and z equals to y. Okay, if you look at this condition here, is that the same thing as saying that z is the maximum of x and y? Think about it, okay? I'll read this one more time because I know some of you are new to the mathematical notation. So we'll just go ahead and read it out read it out aloud. X is greater than y and z equals to x. If you just look at this one here, we only have two variables. Does that mean z is the maximum of the two variables, x, y? Yeah, okay, that makes sense. And then the second one is x is less than or equal to y and z equals to y. Does that make z the maximum between x and y? Yep, okay. This is or. So that means if x is indeed the maximum, this takes care of business. On the other hand, if y is the maximum of the two, this takes care of business, which means this whole expression here is consistent as saying, oh, z is the maximum of the two variables x and y. Are we doing okay so far? But x has no particular value. Y does not have any particular value. I cannot trace the algorithm not knowing what is the value of x and what is the value of y. But I can still perform the mathematical analysis and come to the conclusion that no matter what x, y value you throw at this algorithm, it will still do the right thing to make z the maximum of the two. Okay, can everybody see how this is different from a trace? Because you can throw test cases to a trace and say that, oh, by the time we get to the post line of a trace, the answer is right. Well, yes, it is right for that particular test case. Can you be sure it is also correct for the next test case? Maybe, maybe not. But this is mathematically saying that no matter what the value of x is, no matter what the value of y is, z ends up as the maximum of the two. Done. Conclusively. Is that okay? All right. So that's the important part of deriving the pre and post conditions of a program because eventually you get to the bottom, the end of the entire algorithm, and you can mathematically describe what that condition is going to be. Is that condition what you want to achieve? That's the question. Okay. So the conditional statement is a little bit, I can do it in a much more graphical way. So the start is before line n. This is on line n. Line n asks, is C true or false? If it is true, we go on this side. Now, the branch itself, the arrow itself, says whatever is true before line n is still true because the evaluation of C does not change anything. So whatever was true when we started off the whole thing is still true. But in order to end up on this branch, C has to be true because of the control structure of a conditional statement. So that means right before line n plus 1, I know not only is pre-n, whatever condition that turns out to be, is true, we also know condition C also has to be true. Is that okay? And then likewise, if we go to the else branch, we also know that C has to be false. This is negation, which is the same thing as a single exclamation point, which is also the same thing as the word not, N-O-T. Okay, so that's how we can derive the precondition for the entire then block, the condition before the entire else block. What the post condition of these turn out to be depend on the statements of these two blocks. So I cannot make a general statement about that. So I can only describe the post condition of the then block as post n plus 1 because that's the last line of the um, then block. This side ends with post n plus t plus c plus e plus 1. That's just a line number. Okay, it's the last line of the else block. So the question is, what does the merge do to the post conditions? Well, you can either go this way or you can come this way. So after we merge, we cannot tell which way you came from. So I can only make a conclusion of, well, it can be this or it can be that. That's the only conclusion I can make. Now, this is all abstract using terms and symbols that you are not familiar with, but you can give yourself an analogy that is easier to understand. Okay, so let's just say that at the entrance of this building here, it will give you a question. Okay, it says If you're wearing a black jacket today, this is what we need you to do. If you are not wearing a black jacket, this is what we need you to do. Okay, after these two processes, you continue to your classroom. So by the time you get to the classroom, I don't know whether you came from this side or this side, but I know that it has to be one or the other. I can come to the conclusion it's one or the other. So it's kind of like that. Okay. All right. So we're out of time today. Okay. We are, we went through some of this module. Okay. I still have to cover the loops. Okay, which is even more interesting in many, many ways. Um, but prepare for your exam one on Monday. It is open book, open notes. Make sure that you bring along all the pieces of paper that you think will help you. Make sure you bring along your own writing instrument. Okay, don't forget to bring your pencil or pen, and bring extra pieces of paper just in case you need it. All right, and I still have office hours tomorrow and on Friday, and also right before class on next Monday in case you need to talk to me.